let's actually write out the summation for our maximum algorithm. Okay, so we have an algorithm maximum of some array A. Okay, well, first of all, we just give it a new name for reasons. We simplify it. So we have our function is called T of n. Okay, function name, problem size. Okay, to express this as a summation, we're going to have a summation to start with. Okay, we're only dealing with a single for loop. Okay, so basically this is going to summarize our for loop. Okay, and let's remind ourselves what that for loop was. Okay, so from 1 to the length of the array minus 1. Okay, so then it was from I equals 1, and then it went up to the size of the array minus 1. Okay, does everyone agree with me that that's a really new way to look at for loops? Complete silence. We've been looking at this for years. Not really. Okay. For some, that might be a completely different way to think about a for loop, but basically, this will count the number of times this for loop executes. Okay, so I don't know, it's maybe I'm taking a tangent here with 17 minutes left, which is always dangerous, but again, think about as some of the things we go through this course, we used permutations to be able to work out the number of outcomes of a shuffle algorithm. Now we're using asymptotes to establish limits that our functions will not pass. So it's kind of interesting how we just start to pick and borrow things from mathematics that really help us explain conveniently what's going on. Okay, now the only other thing I need to count is the basic operation. Okay. So what is a good value for the basic operation? I need to write something here. Okay. Do I write a constant? Do I write a variable? Well, the basic operation will happen once, okay? So basically the cost of the basic operation is 1, it's constant. Okay, so basically then we have our summation for this algorithm. Okay, and again, this should hopefully, if I go back to the summation rules, we can see that we can take advantage of this and just take the upper limit, negative the lower limit plus 1. Okay, so then I can say that is the upper limit, which is n minus 1. Let me just label that. That's upper, that's the lower. That was a really bad attempt at an L. Okay, and minus the lower limit, which is 1, and plus, was it plus 1 at the end? I always forget, plus 1. Okay, that's why we review the summation rules every single year. And we simply just, okay, well, we have n minus 1, minus 1, minus 2, plus 1. So it is n minus 1. Okay, so we arrive with a result here. We can actually see that this, our function t of n, is actually a member of the linear order. Okay, or we can say theta n or something else. Okay, but we can basically arrive at, yep, we've got our order of growth. Now, just worth noting that we just throw this away. We don't care about the extra constant. Okay, so that worked out pretty good. Okay, so we had our for loop and we had our basic operation. I should really put an arrow in there, otherwise that's super confusing. Great.